I just wanted to get the opinion of the panel as to bioengineering the environment as a means of abating global warming.
This is the Margaret line.
Right, I wasn't on there. We manipulate so much of the biosphere now. Correct me if I'm wrong, Emmett, but isn't 2/3 or 3/4 of all the nitrogen that would normally be made by plants and bacteria, we actually fix and turn into fertilizers now? So we dominate the nitrogen cycle. We're dominating the carbon cycle with all the CO2 we're generating as our activities as a species. So there are some suggestions that perhaps we can use our ingenuity, since we're already manipulating things at a large scale. Let's try and manipulate things at a large scale for the benefit of the planet, and this is called geoengineering. And there's a couple of proposals that are being investigated by the private sector, and we actually had a scientist at VIMS talk to us about this a couple Fridays ago. And one scheme is to go to areas of the Earth's ocean where there is lots of nutrients except for iron, which has recently been discovered to be an essential micronutrient for the algae. To go to these places and drive around in ships and dump solutions of iron sulfate into the ocean at a huge industrial scale. Now, ocean scientists have done this already to see whether this iron hypothesis was actually supported or not. And they have been able to make big blooms of algae in these areas of the Southern Ocean near Antarctica and elsewhere. And these patches are on the order of maybe 10 miles by 10 miles or 10 miles by 50 miles. And the scientists that are now ramping up these companies and studying this further say that, well, if we scale this up to maybe 100 by 100 miles or 200 by 200 miles and do maybe a dozen of these things every year, that we would be able to cause so many algae to grow that they would take the CO2 out of the seawater, which would then cause some of the CO2 in the atmosphere to go into the seawater to replace it. And then when the algae die, they would sink out of the surface layer. And unlike the dead zone problem that I showed you in my second slide, these areas that would be fertilized by iron are in deeper water. So the dead algae with the carbon locked up in them would sink down into really deep water and perhaps be gone for at least 100 years or more. Now, it's not a permanent solution, but it does theoretically have the potential to draw down CO2. And another proposal is to put aerosols high into the upper atmosphere to alter the heat transfer and try and cool the planet by essentially putting an aerosol screening shield up there. Both of these are tinkering with the planet at a huge scale, and there's some very serious questions. What if we get this wrong? What if we reach a tipping point that causes a downward spiral that we hadn't anticipated, given the complexity of these systems that we're only now beginning to understand? So with that, I'll let any other panel members weigh in.
And I guess the other comment I would have is the cost of doing these types of geoengineering is going to be phenomenal. Imagine putting aerosols in the upper atmosphere. That would cost so much because the volume is such a big, it's on a big scale. And so you'd have to have a commitment where you'd be every year putting all these aerosols in, and you would need a lot to make, to have an impact. So it sort of sounds great when you're doing it on paper and you're sort of imagining, but when you actually factor in the cost of doing these things, you might as well just find, new ways of cutting back what you're doing. It's sort of, common sense has to prevail on this. And often these arguments don't have much common sense.
I was just going to add to that, the Earth system is so complex, and we have a very good idea about what would happen, but we can be surprised. And the ozone hole that occurred is the prime example of that. For 10 years before the ozone hole, 15 years before the ozone hole occurred, scientists had a good idea that chlorofluorocarbons would dissociate in the upper atmosphere and would decrease the ozone abundance, and that's true. But the physics by which the ozone hole occurred were not conceived of, and it was only after the ozone hole occurred and a number of dedicated missions to the Antarctic region to figure out why it occurred, and then we figured it out, but the ecosystem behaved in a way which we did not expect. And so that's the real risk of doing geoengineering, is that, we may know so much, but we don't know everything. And the risk of, who would take on the risk and the responsibility if you did a geoengineering experiment of some sort on a large scale and it backfired? Who's responsible? Who's going to take up whatever happens? Because the ecosystem is extremely complex, and we probably won't know with 100% certainty what will happen if we did something. So it's a huge risk, and it's certain if we stop putting CO2 in the atmosphere, we'll eventually decrease the amount of CO2 in the atmosphere and then decrease greenhouse warming. So that's a certainty, but the geoengineering is high risk, in my opinion.
Some of you, like me, are old enough to remember the commercial that was on TV back in the 70s, where the woman in white comes out and says, "It's not nice to fool Mother Nature." And I think that's sort of what we're talking about here. It's both extremely complex, so that the surprises of the sort that Marty mentioned are often happening when we do something on a large scale, and it's also extremely expensive. And so for both of those reasons, it makes much more sense to try and get back to cut down on the energy use and get back to a state where the Earth and the living things are working for us, so to speak, the way they always have in the past.
If I could make one more comment on the geoengineering, and also answer the question that was asked, what's the most important thing we could do right now to cope with global warming? One thing would be to encourage our politicians to adopt the Kyoto Treaty. When you go to Europe, there's a very different attitude and implementation at economic level of all sorts of decisions about CO2 emission. But to play devil's advocate on the geoengineering, I think the risks are huge, and I would not favor it myself, but there are going to be some market forces that are going to drive this in a way that I don't think any of us realize. Right now, there's a trading system for carbon in Europe where the emitters get credits and they trade back and forth. There's a whole economy for offsetting your carbon emissions that's in place because of Kyoto. And it costs about $20 a ton of carbon to offset. That's the cost to the emitters. And I don't know if you're aware that both Google and Yahoo both purchased or put in place contracts to offset 100 million tons of CO2 per year with carbon credits. And if you do the math, they're spending hundreds of millions of dollars to make their countries on paper green or carbon neutral by buying these offsets. Now, you can buy offsets in the marketplace, or you can go get them off market with people that will say, well, we'll plant trees for you. So getting back to the geoengineering and dumping iron in the ocean, when those companies come online, they're going to be offering their services. It's going to be unregulated, and yet I predict there's going to be a demand for their services, and that we will see patches, unfortunately, fertilized at the 100 by 100 mile level or bigger, because there's going to be people willing to pay to say that, hey, we suck that much carbon out of the air by fertilizing the ocean down off Antarctica.